Good evening, all. Thank you, Aisha. Good evening, all. So today my topic is architecture and structures. Since SDI, Structural Design Institute, so I'll be more focusing towards the connection between architectural design and structural design. So that's why I chose this subject. So let's start the presentation. First of all, so we will let's have a look about what is architecture. So architecture basically you can't define architecture into one particular product, not just for a building. So architecture is like designing anything. So you can implement architecture in any design. Basically, it's a form of art in scientific way. We can tell like that. So there are like plenty of definitions and ideas about what is architecture from different renowned architects, different countries, like different architectural practices. So let's go through several of them. Yeah, basically, in a one way, you can define architecture as a principle of aesthetics. So we have a saying called architecture is a mother of all arts. By so basically, in the architecture, you can you have rhythm, unity, properties, balance, and composition. So those are the basically what we call principles of aesthetics. So these are the some quotes from what is architecture. And architecture refers to the art and science of design when it comes to a building. Yes, construction industry and physical structures. So architecture is not only an art, it's basically combined with science and technology. So you can't define architecture as just an art. Sorry. Once you can say architecture is a visual art, and architecture is creating spaces. And in another side, architecture is connected with environment and sustainability. Architectural design always cater for several aspects like aesthetics, function, environment, climatic, sustainability. Likewise, not only one aspect or two aspects. When you are designing, in particular in architectural way, so you have to focus not only one thing but several facts, especially when it comes to a building. Of course, function, climatic, and aesthetics, and one thing, another like structure, how it can be built. Likewise, like I said before, architecture has several impact from several cultures, technological changes, and social changes. So the particular architecture in that time period, it reflects the cultural values and the technological advancement of those particular era, and social changes and social values of that particular era of the designing of that element. we can say it's a building or any other thing. So it shows you the essence of that era. So let's say one so that's how we have several architectural styles we could identify throughout the history, like Gothic, Renaissance, Modernist, and Postmodernism. Those are the main architectural styles that we could identify in history of architecture. Yeah. So, and architecture is so by saying that architecture is not like limited to a building or a product. It's from macro context to micro context. Let's say from urban designing to designing a small interior space, that you can implement architecture and the principles of architecture for that design. So let's go through several quotes from some very famous and renowned architects who has done marvelous jobs in subject of architecture and the architectural industry. As you all know, Zaha Hadid, one of the brilliant architects that we could find in the industry. So basically, Zaha Hadid architecture is like more like different forms and different structural systems, like different spaces. That so I'm not talking about just a space like yeah, there are space very like square spaces. You can make interesting square spaces, but let's talk about bit of beyond that. So where the architecture it becomes the structure of it. The structure becomes the element of the architectural space. Likewise, so the Zaha Hadid's buildings are the best, one of the best example. As we can see, this is one of the best examples from Zaha Hadid work. Some can say Zaha Hadid buildings are sculptures. Yes, you can define a building as a sculpture in a city scale. So that's why so this quote, it's very unique, that it's not just a shelter or a simple enclosure. The architecture should excite you, calm you, and make you think. And another renowned architect, Norman Foster. I hope you all have seen his work. So and Tadawando, different material practice, different kind of spaces than Zaha Hadid or the Norman Foster, but very interesting architectural spaces. Concrete is one of the main materials in its material practice. So the concrete, so let's say once we call concrete, we remind structures. Okay, it's concrete is a structural material. So Tadawando is one of the best architects who has used concrete as a canvas of his art. Louis Kahn, another renowned architect and who has done marvelous jobs. This is Slack Institute. So we will get their works in later stage. And Renzo Piano. So from those three architects, from those several architects, you can see that anyone can give their opinion about architecture in the way that they think and in the way that they practice and in the way that they feel. So you can't define architecture as a just a one kind of a thing as you experience. It's a form of a art with scientific base, with a material practice, and a creating of spaces. What's structure? So that's where we connect with our structural engineers. Once you take your concept and once you take your dream into the reality, once you're going to build it, that's where our structural engineers join with us. So basically, as you can see, that's a classic example how architectural concept has become a reality with the effort of structural engineers and the concept of architects. So yes, in the definition of structure, we can say the structure is a kind of arrangement of elements. So in any form, so that can be in a building, that can be in an organization, that can be a different form of art. The structure is there. How you arrange, how you organize, and how you place that different elements. So let's take a building. The structure is how you arrange your structural elements: beams, columns, slabs, core, structural cores, service cores. How you arrange those. So once you in that practice, so we call several systems, slab systems. So it's a collection of system. A building is as a collection of system. So the structure comes when you connect those systems. When you connect your envelope, when you connect your core, when you connect your floors, slabs, when you connect your roof into a one product, the structure comes in the action. So the way how you connect those elements. So this is another definition for a building structure. Structure of a building. So structure of a building refers to the framework, a skeleton that provides the stability for that particular product. Let's say this can be like, as I said before, the structure it's of anything is providing the stability for that particular thing. Let's say a table. The table holds its stability with the structural element of that table, legs and the connectors. Those are the structural element which holds that table in a very steady way, right? So same as that building, you have structure which holds your that what we discussed earlier, what holds your particular several systems into one product in a stable way. Yeah. So these are the things that we can identify in nature as a structures. So every things which has been created by nature has its own structure. So let's take a leaf. You have its own structure where it gives the stability to hold that leaves the way it wants to let's say, fit for the function, right, to get the maximum sunlight, to take the attention of the creatures, to provide the needs of that plant. So the one of the best examples in structures in nature is a very small thing, the leaf of a tree. It has its own structure. So seashell. So we are talking about the structural principles and the structural forms. The shell is one of the best example to curve structure, right? So in our in our first year, so we have a subject called nature studies. From that subject, we used to study about the mathematical order of any product in a nature. Let's say a flower. How the petals has been fixed into the seed bed. So it has its own mathematical order. It has its own structural way how those has been fixed into one particular system, one particular item. So, and the let's say a mahogany seed. So that structure and the design of that particular natural thing, it's give the maximum efficiency to do its job in the nature. So the mahogany seed is a seed which travels with the air, right? So it has a small wing like that. So once the seed got out of from the fruit, that structure helps the seed to get far as can from the mother tree, to spread the its own kind, and so that so those are the very unique and very simple examples that we can get from the nature. Right? Of course, let's our own body. So just imagine without a skeleton. So we have several systems. We have nerve system, the skin, we have one system, and our muscles, our organs, and those all systems are holding as one item with the skeleton. And it's connect several system into one particular design. Simple as that. So that's why I told you previously, you can so in the architectural way, we call building as a collection of systems: structural system, envelope, MEP, HVAC systems, electrical system. And end of the day, if you don't have a structure, so ducts can't stay floated, right? So your envelope can't stay like just floating in air. And the structure what makes all together. So let's talk about how we design the structure in later part. So I would like to take this session as a discussion with the structural engineers in front of me, and also the audience who is joining in the online. So so I came in architectural part very quickly, because just to give you an idea about how we define architecture and what is architecture, because you should know like to have an idea what is architectural design. So basically, I'm focusing in this lecture how we can create something extraordinary in by let's say by addressing the architectural concepts as a structural engineer. So as an architect also, how we can blend those two together to achieve a extraordinary design, extraordinary build, let's say building. Of course, we all design buildings, architects. Yeah, so we design other things also. But in this particular session, I will talk about buildings. Huh? So these are the very brilliant and very small examples from nature. So that's a wing of a fly. Right? So as a structural engineers, you can identify the structure of its own. If there was that membrane only, that fly can't fly. That structure has to be there to function it and to really make it happen what it has been made of made to, right? So basically, so if you have a wing, if you can't fly, there's no point of having a wing. So by adding a structural like elements from nature, so it has given that purpose to that wing, right? Skeleton and the beehive is one of a brilliant example from nature for a structure from that octagon space. Same. So I think as a structural engineers, you know the basis and how that octagon shape can be transferred to a structure, right, in a very different way. Not like, so I'm not talking about just beams and columns here and slabs. Not like that, right? How we can create a something. So yes, as I previously said, the square shapes spaces, we can make it brilliant square shaped spaces by very simplified columns and beams. Yeah, we highly appreciate that, but I'm talking about something beyond that. I'm repeating that. Yeah. What is design? So this can be an architectural design, this can be a structural design, this can be a furniture design, this can be a design in a like MEP system, this can be a design in a like a graphic design. Once we design something, there are like three main elements, three main facts that we should really consider. Right? Creativity, intuitiveness, consciousness. Those are the three main things that we really focus while we are designing. The creativity must be there to achieve something which has been never seen. Right? Designing is not just designing like some. I'm not talking about a design just a okay we have seen that. So that design won't take any place in the industry. Okay, we have seen those. We have seen plenty of those. But if you create something creative, okay, that will mark your name in the industry. That will keep that particular building or that particular product in the memory of the people. Right? So we have seen plenty of historical buildings. plenty of historical buildings. But from those plenty of historical buildings, those are very limited number of historical buildings, which we can remember as okay, close here. One of the best example. Pyramid, one of the best example. Right? In Sri Lanka, of course, stupas, right? One of the best architectural and structural products, right? But let's say, yeah, we have seen plenty of stupas, but Ruan Valley, Chetavana, and Abhayagiriya is the first of all. If we talk about a stupa, one of three those will come into your mind. Correct me if I'm not wrong. If I'm wrong, right? For me, when we call stupa, yeah, Abhayagiriya, Chetavana, Ruan Valley. Why is that? Because those are the key historical, architectural, and structural products that we can remember because of its size, shape, and the greatness of that particular designs. Right? Elements of design. As I said before, elements of design can be applicable in any design. Architecture, yes, we play with lines. We create space with shapes. We create buildings with forms. We are talking about texture. Once you create in a space, we are talking about this wall I need in this texture. I want this wall to be with a rough texture to give that sense of the space, right? The value, how it has been spread, right? And the color. Right? So in terms of structural design, of course, the value and color may not much applicable. But the 5 of very first items: line, shape, form, space, and texture. Texture, yes, of course, texture also very valid in the structural design also. And just have a thing. Just think that how you design a structure, how you design reinforcement. It's all about the spacing. It's all about the form that you have to address. It's all about the shape that what you're gonna achieve in the construction. It's all about the lines, what you have. I mean, like perimeters and the voids and all. Right. So those elements of design, we can actually we apply those without knowing. Right? So let's have a look about principles of design. Principles of design: contrast, repetition, alignment, proximity. Contrast, okay, we can say in architectural design, yes, we contrast building from the nature, or we hide the building from nature. We contrast building from the rest of the area with a different material, with a different form, different shape, and with a scale. And the repetition of the items, the repetition of the elements. And so let's go one slide back. The repetition of the lines, the repetition of the space, the alignment of the lines, the alignments of the shapes, the repetition of particular forms, texture. So why I take these two slides, just to give you an idea in design, but in generally design, we all do these, we all do use these 4 principles and 7 elements, whether we know these are the principles of design or the elements of design, whether we do or whether we know or not. So, but as you can see, those principles and those elements are in every design. Architecture and structure. So actually this is our real topic. How we call architect, what is the connection between the architecture and structure? Architecture and structure, interconnected concepts. Interconnected concept, not two different concepts. So in our industry, I know, like, as I think, there is a cold war between architects and structural engineers. Architects only know to draw. Engineers only know to put some beams and columns in our designs. That's a cold war. Right? Correct me if I'm wrong, but as per my understanding, there's a cold war between architects and engineers. Right? I'll show you several great examples where that cold war has some peace. Right? So this is, as I said, one of the best examples how the architecture and structure has been blended and create a massive, marvelous design and the marvelous building. Sorry. So the next question: can structure influence architecture? Can, so normally we are talking about, so that's why I told you I have this focus this discussion more towards the structural side, right? Not the how, not very like conceptual architectural, not into that level, but to a very simple connection between architecture and structure. That's all. Not very sophisticated one. Right? Can a structure influence architecture? Yeah. So let's take high-rise building. If you want to do a high-rise as an architect, you have to get influence from the structure. As a structural engineer, if you want to do a high-rise, you have to get an influence from the architectural concept. So Burj Khalifa, one of the greatest architectural design as well as the structural design. So Petronas Tower, I'm not knowing about this tower. Right? Yeah, structure itself influence architecture. Actually support architecture. Architecture itself influence structure, support structure. So these are the several work from renowned architects. You may see these like, no, you can do it. You have to do it if you want to make an exceptional character in the structural society and the architectural society. So these are the, as I said, Louis, yeah, Louis Carnis. See how that structure has become its own architecture, how that architecture has become its own structure, that form. So I'm suggesting you to uh, see some work of Zaha Hadid, Santiago Calatrava, Le Corbusier, Louis Kahn, Eladio Diasti. And in terms of not about the details in architecture, but the structure, how the structure has become a very support element for that architectural concept. You can see here very well. Basically, this area you have this architectural element. These 4 shadow lines. Just imagine you don't have these 4 shadow lines. Will you have this image? Will you have this feeling of the building? No. You just imagine you can't do this curve this way. Just that structural system has given its best to the architect. So these are some interiors. See how that structural system has become a element in the interior. You just imagine having a column here. Just you're done with that space. So that this is where the structural creativity and architectural creativity blends together. This is where the structural concept and architectural concept blends together and makes some extraordinary. Wolfberg. Concrete. Once we call concrete, we remind foundation, pile, beams and columns, shotcrete. These are concrete walls. These are concrete structural elements, which has become architectural elements in those designs. That's why I told you before. Architecture and structure is interconnected. Not two system in a building. It's a one system which holds together, which holds all the other systems too. See, this is a structural system. How it has created these spaces, architectural spaces. This architect, she wanted to have these things. If that structural engineer said, no, I can't do that. I want to have a flat slab, 300 millimeters or 400 millimeter, top net, bottom net, flat slab. No Zaha. You can't have this. See this concrete form. See. Architectural concept. This is where the engineers tell, okay, architects just only draw. No. it's the first thing it come into your mind, the concept while you are designing the building. Yes. For me, it's a yeah. For me, different architects has different approach. There are there may be architects in the online session, and so I'm talking about my personal experience, not for the architects or the structural engineers. And yes, as once I get a job to do, if it is an interior job, yes, I I I imagine which kind of a interior that I want, and what is that quality of the interior, the project. If it is a building, what it should be look like. There's a famous called forms follow function. Architectural forms follow function. But there are plenty of against ideas for that form follows function. So you can't you can't say exactly this is what it is. It works both way. Sometimes form follow the function, sometimes function follow the forms. Here what has happened? Form follow the function or function follow the forms. Functions follow the form, but in a very creative way. In a very creative way, you don't feel it actually. These functions have not just put into that form. From that form, the function has been catered to the next level, the maximum level. Right? I'm just showing you several images. Right? If you can, this take a note of the building and just go through a document how this has been built, how this has been designed, how that particular structural system and the architectural concept has been blended into this level. What is the construction method that they have used to achieve that? It's a sculpture in the cityscape, supported by the structure generated from the architecture. See how this glass facade, how it has formed, is shaped. This facade is curved in this way and this way. If that structural engineer said, no, Zahid, you can't curve it in this way, you can only curve it in this way, what will you get? See, construction, how those systems has catered, how these structural elements has catered into the interior, how it has become a piece of art with a scientific base, how it has been constructed. Santiago Calatrava, you must have heard of him a little bit, no? Architect and also an engineer. I'll just go through several slides. Just have uh, just have a look, huh? That's Santiago Calatrava. How that architectural concept has been addressed from the structural systems and create that marvelous spaces and the buildings. Santiago Calatrava is one of the greatest example to the combination of structure and architecture. So, okay, let's think we design something, small house. You get the architectural drawing to locate the structural columns. You simply have a, okay, what's the first step? You put the structural grid. As I know, correct me if I'm wrong. And you locate the columns as per the span, and you design the beam as per the span and like space between the columns and the slabs as per the area. Okay, you have 150 wall in architectural design. You put 225 column in that 150 wall. Here comes the column out of that wall. That's spatial quality of that space gone. I'm not asking you to exactly follow the architectural design. I mean architectural drawing. Like I'm not asking you to exactly as it is, because there are constraints in structural design. I understand. There are things that you can do, there are things that you can't do. Right? But try in the maximum capacity to achieve that spatial quality of those spaces. To do that, you should design something new. 225 column is like a general thing. Okay, let's make it 150 by 400. Okay, let's remove a column and put a 150 concrete pier wall in that particular space and get that clear space. Very small design, but have a huge impact that architectural design, but have a huge impact that spatial quality of that space. Just imagine we have two huge beams crossing over this soffit from this in this boardroom, from this scene to that end. We have a beam right here and we have a beam right there. Gone. Those are very small things, but has a huge impact on the design. Architectural concept, how it has developed into that structural design and the architectural design. It's like a person holding a fan. So, okay, how it has evolved in the design process, how it has come up to the reality. Just go through some of his work. See some. There are plenty of videos. From Zahadid, there are plenty of designing videos. Okay, you might think, oh, okay, they have this software and that software. Okay, you can have there's a software in Zahadi when it's like a net. So when you grab one corner of that net and you take it to the point that you want, and the structural elements, so it creates the structural element of that design, right? But we might don't have that facility. We might don't have that resources. But by knowing that this can be done, and this can be done in a particular way, then you can try what are the creative ways to do to get it to somewhere nearby at least. අපි අර සිංහලෙන් කියන්නේ හන්දට ගැහුවොත් ආසය හරි නවතින්න පුළුවන්. Right? At least study these kind of innovative structures. And what are the natural, what are the inspiration from nature for this design? And what is the concept? See. What you can remind first when you see this structure? Simply a skeleton. Simply a skeleton. Right? See, your spine, yeah, the ribs, your main two elements. See, and the shell structure. See how these buildings has created their forms and the shapes, the use of those four elements of the design, lines and the shapes, space. Even in the bridge designs, when you have a bridge to design, all you think is a span, and if it is tensile, where I can hang this, what is the minimum or the maximum span that I can achieve, how many posts that I required to get into the next band. But creating something extraordinary, it should come from your, like, yeah, we should at least have seen those kind of works. Then only you can imagine, okay, okay, something like that, whether it can be applicable to this particular design. This is one of a classic example how the structure has, see, the interior. See the exterior system, envelope. Eladio dynasty. I don't think any of you has ever heard that name. Concrete is not only material that you can do marvelous. This is brick. That's why I tell you, some of architects, they define architecture as a material practice. Structural design also same. Don't get restricted for only for concrete and steel. Research on the other materials. Bamboo, one of the best structural material that you can achieve good tensile. Bamboo has a good tensile properties, I think, and lightweight. See how Radio Dynasty. These buildings are very old. 1958. 1958 at Uruguay. Have you seen any single building in Sri Lanka like this? We always a single enclosure once a Balgano. We had a 2,500 history, and we had 1 inch slope to a 1 mile. But do we have any single building like with one of these structures? See, this is a shopping center. Brick walled structures. Look at that roof. Look at this. How this can be done? I'll show you a very interesting one of the Villario dynasty. My gosh. It's a petrol station. Right? Let's forget about Othana. Let's forget about that. Right? Forget about functionality. Can we do something like this? Even in the concrete? Marvelous work. I was obsessed with his work in grade 4 of the university. See, very simple, no? See, this is what we're talking about. How that force does work, that structure. I don't understand this, but I know something is structural, no? Right? To be honest, I'm not like a structural engineer. I think you can understand this, no? No? Okay, let's get to our end. So actually from this discussion, I just wanted to make some like say a passion interesting just to go through let me repeat those architects: Saadid, Santiago Calatrava, Louis Kahn, Eladio Diasti, Frank Gehry, Tadao Ando, Frank Lloyd Wright, very straight beliefs, but Norman Foster. Just go through some of their work as a if you're interested, and see how it has built a remarkable elements in that cityscapes, landmarks building. So as a closure, so I'll tell engineering is more analytical studies, research, safety, quality and standards, calculation, equations, simulation, load, stability, and material properties, logical and scientific, no technical approach. Architecture, principle of aesthetics, space, form, materiality, context, culture, functionality, meaning. But this is no, it's not non-technical approach. Most of people think architecture is a non-technical approach. No, it's not. It's a technical approach that can be supported from structural engineering. Right? We don't design like blindly. We don't draw anything blindly. We know, okay, structural design should do a structure for this. Right? This is no. As my conclusion, I ask you to be little bit creative than just designing structure separately and architecture separately. If architects are joined in the online, I'm requesting them to understand basic engineering. Right? So by doing that, I hope we will get to a point at least 1/10 of Sahadid. Okay. I think my 1 hour is almost finished. So do we have any questions? From who?
So the first question is, someone has said, Mr. Nalika has said, the problem in Sri Lankan structure, in Sri Lankan structures, that is limited to traditional shapes due to the lack of funds. So what would you suggest for that?
Lack of funds. Yes, we are facing some economical crisis. Yes, our clients are not that great like Zahadid's clients or Santiago Calatrava's clients. But I think I'm not asking you to do designs similar to Calatrava or similar to Zahadid, but try to innovate some, okay, let's say we are talking about low cost design, right? So to be low cost, should it be shaped like a box to be a low cost? No, no, you have different material, right? That's where we really need structural input to build something extraordinary with a recycled material. Recycled steel. Use recycled steel. Huh? Use some railway tracks, old railway tracks. Get the input from a structural engineer. Huh? Use some all concrete blocks for the concrete. Use some building debris for the concrete. Not the metal. We have a concrete with plastic here. We have a concrete with pieces of rubber slippers here, right? So, I'm not just asking you to design something similar to this, but I'm just trying to make you curious, huh? What we can do if we get out of that box. Box is fine. I'm repeating. Box is fine. Great shape. Perfect spaces. Right? Because most of the architects will hate me. Right? That man has said it's box. Get out of the box. No, get out of that box. You can worship the box, but you can create something different also. Right? To do that, that's why we need really structural input. And how to design a 2 inches slab. What are the innovative material? What are the cost-effective material? What are the material? So that's why we really need that research and development in the engineering for the cost-effective material developments. So yes, of course, our clients are not that rich, but we can reach in the creativity. That's my answer.
Right, thank you. So there's another question. There are a few on the lines of budget. So one person is asking whether a client is expecting a budget-friendly residential development and they're looking for some modern architecture. What main factors would you consider when designing? How would you achieve that?
So modern. So first of all, can you repeat this question, please?
All right. So when a client is expecting a budget-friendly residential development and they are looking for some modern architecture, what are the main factors that you will consider when you're designing?
I will consider very effective structure, right? With the modern. Okay, so we can take this question to the next level. I can ask that person, what is the modernism? You think about these forms are the modernism. Huh? The modernism is how you practice. So according to me, yeah, not a citation from any other, not a definition. Yeah, the modernism itself is a cost-effective design. Right? So there you can, yeah, the client is asking budget-friendly design. Right? That's the we can connect this to the same question that we replied previously. Okay, let me take some Sri Lankan architects, right? One of my teachers, Milinda Patiraj, and I haven't put their works here. Right? Very cost-effective material. So that teacher is like is telling us architecture is a material practice. And play with some recycled material. Play with some okay, if you really need something extraordinary, something like some curved shape, so find a new way to do that curved shape. So we saw LRU diced work, brick, little bit of reinforcement, and a very thin layer of concrete. So to cater that client's need, we have to dig it new material palette, recycle sustainable material palette. Yeah. So that's why I'm asking you to get out of that box. Conventional concrete columns, conventional brick walls, conventional roof material.
Question. Someone's asking, what is your idea of low cost? It might be connected to what you've already answered. What is your idea of low cost structures that are needed in developing countries?
That will be based on the lifetime of the structure that we are talking about, right? So, so if we are talking about something should stand 100 years, you should spend that money for that structure. If something we are talking about, which we focus in a 5-year lifetime, go for like very bamboo is a good material. So if you can see Rapa architects work, Sri Lankan architects, very young architects, and Tirina Ratnayaka and Padmapani, they do like bamboo works in very creative way. So bamboo is one of the best material with in the terms of cost and the structure. So likewise, so we have to. So this is connected to the previous question as well. So yes, with the in terms of structure, the cost effectiveness like less sophisticated designs, right? So where you have minimum, not like minimum, like not like very large spans, right? But you can, so these most of these people are referring to a small house designs, right? You play with your elements of the house to create a very minimum structural cost. Without having like 25-meter cantilever or likewise, right? Right, for to do that, yes, of course, I showed you several those kind of things, right, which can be applicable in the like bigger scale, right? In lower scale also, these kind of shapes and spans may not work, but the material with the materials and the form, we can create something modern in a very small spaces.
Like compact buildings.
Compact, yes. Let's take 10 by 10. How we can manage that 10 by 10.
The next one is, can you, this might be related to what you said about materials. Can you briefly explain what are some of the problems that aren't solved yet in the architecture field to ease the structural engineers' work?
Sorry, I didn't get it.
Can you briefly explain what are some of the problems that aren't solved yet in the architecture field to ease the structural engineer's work?
Why we need a structural engineer for ease work? Let's say අපේ clients ලා කියන්නේ මාත්‍යවක බාසුනයකට design කරත හැකිනේ කියන්නේ. මාත්‍යවක කම්පියුටර් බාසුනයක් දායි මහත්තයා කියනවනේ අපේ client. So okay, I'm not here talking about ease work or less work or like less creativity. I'm talking about here, come take your design up to the next level, take your design to the creative level which you have never worked before. To achieve something which you have never worked before, you have to work hard and you have to work smart. Ease way is not the smartest way or the hard or the right way to use it. And ease way is to the way to be comfortable. So structural engineers works. So I can't comment what is the ease that particular person has been referring to. But I think there's no need to ease work. Let's do some creative work.
Just to add to that now, since he asked what are some of the problems that aren't solved in architecture, are there any interesting topics that you feel that haven't been really addressed enough in the field of architecture? So some of the materials that you mentioned and using those would fall under that.
Yes, yeah, material practice and the research and development in material. Yeah, so those are so that's why I told you I mentioned about architect Milinda Pathiraja, one of our senior lecturer at University of Maratua. Yeah, you do research on the material, you do research on the details, you do research on how you compose those in a creative way. So this is more related to the architects. And so I was not much focusing on the architectural side, as you can see. I just wanted to make you bit curious about the architecture and structure combination. So there are some not unaddressed, but less addressed. Right? Yes, in Sri Lanka, engineer Halwathura from University of Maratua, one of the best young engineers in the world, who has won the best young engineer award also. So see some work of engineer Halwathura's. So they are one who really try to make something out of research. Right? So they do research on material, mud brick, right? Mud concrete. So those kind of, actually we should have more architects, more engineers in the research and development of material development. Right? Yes, we appreciate the other as well. But I think in Sri Lanka, yes, we do have some of a lack on the material development. But we are trying to do something out of which is available in the market. Architect Vijita Basnayaka. So look at his work. One of our great architects in Sri Lanka right now. He's using recycled material and the small details from like village itself. Not very technical detail, but very simple details where a village person can do. And the material, recycle material. Look at that works as well. Those that architectural concept and that architectural material palette and that architectural quality is not Zahadid quality. Yeah, I should mention. It's not what we talked about. So I was talking about something else. But with which is a Basnaika's works like a recycling material and all. So we highly appreciate Sir's work. Yeah, likewise. And try so as a structural engineers, so you guys try to make some innovative forms and all with the recycled material. So that's the way forward, as I think.
One person has commented, I think, on something you said earlier during your lecture. It says, I cannot agree that Sri Lanka doesn't have structures that use materials other than for concrete. So what about the Ruan Valley Zaire? It is a hemisphere structure and an engineering marvel, as many foreigners have done research on that. Mentioned stupas earlier as well.
I was talking about Ruan Valley Zaire and Abhayagiri and Jetanaramaya. I was referring to the structures which is built after independence. Yeah, we have 2,500 years marvelous history. Yes, I studied history. I have stayed in Polonnaruwa for 5 days and been in every rooftop of the Tuparama, Tivanka Pilimagaya, and those wall structures are like yes, architectural marvels on those days. Other than let me answer that person. I'm not referring those era. I'm referring this era where we do really work here after independence. Let me tell this in Sinhala. Suddha hadapu පාලම් ටික ඇරෙන්න සුද්ධ හදපු කෝච්චි පාරවල් ටික ඇරෙන්න එක කෝච්චි පාරක් කොහෙද ගියේ බෙලියත් එකට ගියා ඇරෙන්න රත්නපුරේ කෝච්චි පාරක් තාම අවිස්සාවෙල්ලෙන් ඉවරයි. I was talking about that. Not Great Stupa, not Lowa Mahapaya, not Satmahal Prasade, not Parakram Bahu's Maligawa, not Nishankalata Mandapya, not Sigiri, of course. Right? So those are architectural marvels. That's why we have become a nation with great history. So that's why I ask him, where's that talent? Where's that creativity?
Past 100 to 200.
It's in the past 100 to 200 years. Yes, of course.
Last question. What is your thoughts on using steel or wooden framed walls or insulated panels in Sri Lanka for residential construction? What is your thought on availability and cost comparison?
Wooden panels and the insulated walls in Sri Lanka. I think that person is referring to interior walls, right? So in Sri Lanka, we have heavy rainfall, right? We have heavy rainfall and we have very challenging climatic changes in the 1 year, like not like autumn, spring, and summer, right? And the winter. But in rain wise, we have like very challenging. So that's why our waterproof doesn't work so much, right? Humidity is an issue, right? Yes, of course, wooden panel walls are good, but using it as an exterior walls will cost you a bit. because you have to really treat those to use as an exterior material. Let's say let's get a classic example of a swimming pool deck. If you go for natural timber, මහත්ය කුඹුක් නම් හොඳයි කියලා තමයි කියන්නේ. Yeah, කුඹුක්, mill, those kind of timber, it's really good for outdoors, but highly expensive. And you can't find kumbuk. The cutting a kumbuk tree is like a crime. So we can use. Then we have to. That's why I asked you to develop a material. So that's why we really focus. Okay, rather than putting all the timber in a garbage. Okay, if we can, if we can create a, if we can develop a engineered timber which can stand on the rain, can we really do that? Can we really do a research on material? How we can make a product out of timber, out of like recycled timber, create a material which is more like similar to timber, which can use in outside. So that's where we need our research and development to be addressed.
So those are the questions from the online participants. Any over here?
Any offline participants has questions?
Architect Nishan, I think the main thing, the message that we're trying to give people as well, is to try and inspire them to be a little more creative, to try new things.
Yes,
so that we can develop.
Basically, my idea. Don't think architecture as a separate thing and a structural engineer as a separate thing. As a structural engineer, try to support architect's concept not to your maximum level, but 2 steps than that. As an architect, that's my request from my structural engineers. Because, and as an architect, from my colleagues, from my architects. So what is the request that I can for them? Think about the structural systems as well while you are developing your concept. Not like, I'm not saying most of the architects doing that, right? I'm not saying that. So most of the architects, so they do have scientific and the structural idea while doing the designs. But yes, that's the conclusion bit. So this lecture was more focused the structural design institute, right? So my request from the structural engineer is like, try to back up the architectural concept as much as possible, even little bit more than the possible. Thank you all.
Thank you so much, everyone, for joining us for this session. Thank you, Architect Nishan, as well, for taking time to speak to us today. I hope this session inspired you a little bit. That is, whether you are a structural engineer or whether you are an architect. And especially in Sri Lanka, as a developing country, even though we're having an economic crisis and so on, for us to develop using what we have studied at the moment, but the materials we have available, looking at the structures that we had in the past, to try and develop a little bit so that we can reach the global levels
of the global level of structures that Mr. Nishan actually showed us as well. So this is to inspire all of y'all to try and reach those levels, whether it be within the next 10 years to 50 years or so on. So thank you so much, everyone. Just a little reminder, we do have a couple of courses that will be starting soon. These cater to not just the structural engineers, but we also have a Revit architecture course, which will be very useful for the architects who are with us. So we will be focusing a little bit on BIM. We have a BIM specialist who will be doing this session, and he will be telling you a little bit about some 5D BIM projects that he has worked on as well. So if you are interested in joining any of these sessions, please do contact us on either LinkedIn or WhatsApp or whatever it is, so that you can register. Thank you so much, everyone, and we hope you all have a lovely day. See you all in the next, see you all at next month's webinar.